Hi everyone, it's Math with AUB. I have sorted out 2 to 3 questions based on a remainder theorem, or you can say division algorithm. When a number m is divided by 7, the remainder is this one. When m plus 5 or 3m plus 7, 3m plus 5, 8 is divided by 9, 8, 18, what is the remainder in that case? Division algorithm, it states that any polynomial or number, suppose polynomial p of x is equal to q of x times, you can say, m times plus r, or any number quotient times divisor plus remainder, quotient times divisor plus remainder, quotient times divisor plus remainder. That is the strategy or formula that we have to follow in these questions. In appearance, this is not regular mathematics, they are hard nut to crack, but follow the definition, think through by definition what do you mean by algorithm, and you are going to get through. Always stuck to definition, always stuck to definition, work within the parameters of definition, and you are going to get through. Our question number 1 reads as, when z is divided by 9, z is any number, divided by 9, remainder is 3, remainder is 3. When z is divided by 9, remainder is 3. What is the remainder when 3 times z? What is the remainder when 3 times z is divided by 9? How division algorithm works? Really very simple enough. Try to follow me. Z is the quantity divided by 9 gives us a remainder, that is 3. Z is the quantity to be divided by 9 gives 3 as a remainder. We have no idea how many times table of 9 is applicable on Z. How many times table of 9 is applicable on Z. But we are sure that it must be some integer time. Positive integer times 9 is applicable on this one. I can write according to Division algorithm Z as, suppose our quotient is m. 9 times m plus remainder. Look at this, the given number z, the expression z, 9 divisible by 9, table of 9 is applicable on z, m times, where m belongs to natural numbers, quotient is never be negative, 9 times m plus remainder. Now proceed and you are going to get through. 9 times m, what is the remainder? That's 3. Now we have some sort of value of z, or what is z equal to what? It is our 9m plus 3. Utilize this one. 3 times z, multiply 3 throughout, 3 times z, 3z, that's the value of z. It will become 27 times m plus 9. We have prepared 3 times z, It is divided by 9. It is divided by 9. Divided by 9. It is completely divisible. So in that case, remainder is 0. In that case, remainder is 0. So option number D is the right option in that case. Follow this one. That divided by 9, remainder is this one. Suppose I'll generate the quotient m times, where m belongs to any natural number, 9 times m plus r, and you are going to get through. Another nut to crack. If a positive integer x leaves a remainder 3 when divided by 7, x divided by 7 leaves a remainder of 3, x, when x leaves a remainder of 3 when divided by x divided by 7, remainder is 3. So prepare value of x is equal to 7 times m. In the same token, 7 times m plus remainder, where m must be a natural number and remainder is given to us, a remainder 3. The positive integer, a remainder of 3 when divided by 7, it is divisible by 7, remainder is 3. In that case, x is, here it is mentioned, 7 times m plus 3. Now we have prepared the value of, a rough sketch of the value of x, and it is going to get through, and we will solve through. X plus 11 is divided by 7. X plus 11, that is value of x. Adding 11 both sides, we have 7 times m plus 3 plus 11. It will become 7m plus 14. 7m plus 14. We have to find the remainder when this expression x plus 11 is divided by 7. 7. Divide by 7. Look at this one. Completely divisible, completely divisible. So again, remainder is 0 in that case. Remainder is 0 in that case. Remainder is 0 in that case. To me, from both of these questions, this one is a humongous as well as a little bit typical. If x plus 3 over 10 is a positive integer, x plus 3 over 10 is a positive integer, means x plus 3 divided by 10 gives a remainder 0, because it is an integer, means 10 completely divides x plus 3. 10 completely divides x plus 3. It is given to us. If x plus 3 divided 10 is a positive integer, no remainder in that case, no remainder in this case. Then we have to find the remainder of x when x is divided by 5. So we can write x plus 3, I can write 10 times m, where m belongs to natural number again, plus remainder. In that case, there is no remainder because x plus 3 over 10 is a positive integer, means 10 divides x plus 3 completely. 10 divides x plus 3 completely, so remainder is 0. X plus 3 is 10 times m, remainder is 0. So x plus 3 is our 10 times m. We are asked to find when x is divided by 5, we have to find the remainder. X, shift 3 here. X is equal 10 times m minus 3. 10 times 3. Now we have to divide this x by 5 in order to get remainder. In order to get remainder. If I divide by 5, there is negative quantity. Try to convert this one positive mathematically. Then we are in a position to find remainder. Then we are in a position to find remainder. 10 times m, let me write minus 10 and positive 10 in order to make negative 3 the positive. Why I have chosen 10? I take 10 common, and this sort of form is preserved in that case. 10, that's why I have added and subtracted 10. 10 common, it will become m minus 1 plus 10 minus 3 is 7. Now we are in a position after this step, after this typical step, after making this negative 3 positive in order to get a perfect remainder or positive remainder. Now we are in a position to do so. We are in a position to do so. Taking 10 common, now divide by 5. Dividing by 5, dividing by 5. So in that case, remainder is going to be 2. So remainder is 2 in that case. 2 in that case. A little bit this tiny my effort paves the way for you to attempt such type of question with utmost ease. It's all by itself. Next.